All right, so now we're going to divide square roots. And I don't know how many of you are actually looking at the online textbook for this class, but there are two other pieces in this section of the textbook that we will not be doing in this class, and those are called rationalizing the denominator. So again, we will not be doing that in this class. I will not be testing you over it. We won't be doing any of the homework over it. If there is any homework that involves rationalizing the denominator, send me a message because that means I missed it because I really did try to get all of those pieces out of there. Anyways, so let's move on to dividing square roots. All right, so here's the thing about dividing square roots. I can't just divide that 6 into that 54, okay? In order to divide square roots, they have to both be under the radical, okay? So it's kind of like you have to consider it as like terms, only I hate to use that because it's really not what that is here, okay? I can only, since this 6 does not have a radical, I can only divide this 6 with whatever I get on the outside whenever I simplify the square root of 54, okay? So let's go ahead and simplify the square root of 54. That can be written as, let's see here, 9 times 6, right? 9 times 6 is 54 over 6. And then I can take the square root of 9, which is 3 square roots of 6. And now what I'm allowed to reduce is this 3 and this 6. So this would be reduced as if we had 3 over 6 without a radical. And so you would have 1 over 2. Okay, so we would have 1 square roots of 6 over 2. Remember, divided. And really we don't need this 1 right here, okay? It's understood to be there. It is there. It's just not the most simplified way to write it. So that's the most simplified way to write this problem. So let's take a look at this problem. So I can't reduce this 12, this 12 and this 24 because the 24 is under a radical and the 12 is not. So let's simplify this radical first, and then we'll see what we can do as far as simplifying. All right, so I've got 6 minus, and the square root of 24 can be written as 4 times 6, right? Over 12. Now I can take the square root of 4, which is 2 square roots of 6 over 12. Now, here's what I want you to ask yourself. What is a number? And again, we're ignoring this, okay, because I can't do anything with it. But I can reduce the 6, the 2, and the 12. Ask yourself, what is the biggest number that can go into all three of these numbers? Okay, it's not 3 because 3 can't go into 2. It's not 4 because 4 can't go into 6 or 2. So it's going to be 2. We can reduce all three of these numbers by dividing each of these by 2. Okay, so if I divide 6 by 2, I get 3. If I divide 2 by 2, I get 1, but I don't have to write that because remember it's understood to be there. It's just not needed to be written. And 12 divided by 2 is 6. All right, and that's it. You might be asking yourself, could we reduce this further? Yeah, you could. You'd have to split this apart. But really, this is okay since we're subtracting. We can go ahead and leave it like this. And what I mean by splitting it apart is it would look like this. And this answer would work too. So both of those are actually very good answers. All right, so this page is just letting you know that if you have one big radical, it can be written as the numerator under a radical divided by the denominator under a different radical. Okay, so you can actually go vice versa with these. Okay, you can have one big, and you might be asking yourself, well, why would I ever do that? Well, sometimes it helps you to have a big radical, and sometimes it helps you to have two small radicals. So let's just look at different examples, and you'll see what I'm talking about. All right, so this is one of those places where it helps to actually have one big radical. Here, let me show you. 27 over 75, because I can reduce the fraction 27 over 75 because I can divide the top and bottom by 3. Whenever I divide the numerator by 3, I get 9, and whenever I divide the denominator by 3, I get 25. Now, check this out. I can take the square root of 9 over the square root of 25, and I get 3/5 as my final answer. All right, that's it. This is also one of those places where it's nice to just have one big radical. 6y to the 5th over 2y. I can go ahead and reduce the fractions, so I would be left with 3 and then y to the 4th, okay? And then I can actually take the square root of y to the 4th. And why did I get y to the 4th? Well, remember there's a 1 right here. 5 minus 1 is 4, okay? And we had more y's in the numerator, so that's why they're staying in the numerator. All right, so we can't take the square root of 3. That's going to have to stay under the radical, but I can take the square root of y to the 4th power, which happens to be y squared. There we go. We're done. All right, so let's take a look at this one. So let's just make one big radical here, 72x to the 3rd over 162x. All right, if you don't have a calculator that reduces fractions, you need to get one, okay? Because all you have to do to see if this will reduce, now you can't type the variables into most calculators, but the calculator that I've been telling you about and the one that I recommend in the syllabus, I can actually type in 72, hit the fraction bar, and hit 162, hit enter, and it tells me that this reduces to be 4/9, which means that it divided the numerator and the denominator both by 18, okay? And now we're going to go ahead, we have to do the variable part ourselves, okay? So we're left with x squared in the numerator. Okay, so now we can take the square root of 4x squared, and we can take the square root of 9. Taking the square root of 4x squared, we get 2x. Taking the square root of 9, we get 3. And that's it, we're done. All right, so let's take a look at this one. So let's see here. On my calculator, I'm typing in 147 divided by 3. Yep, I end up with 147 ab to the 8th over 3a cubed b to the 4th. Okay, so now I'm going to reduce the 147 divided by 3, and I get 49. The a's are going to stay in the denominator because there's more in the denominator, and 3 minus 1 is 2, so I get a squared in the denominator. The b's, there are more in the numerator than there are in the denominator, and so whenever I subtract, I get b to the 4th. Now I can actually take the square root of every bit of this. The square root of 49b to the 4th is 7b squared, and the square root of a squared is a. And that's it. We are done. All right. So that's it for this video. Again, if you're looking at the textbook, we did not do the whole section, and we will not be doing the whole section in this class. So if you come across anything that looks strange in the homework, let me know, and I'll be happy to give you credit for that.